Rational exponents, part 1. So, what we have here is a simple mistaken identity problem. And the identity, it doesn't make any sense. I don't even know why I started with that, but I am not doing this over again. Okay, not that that was like a long time. That was like, what, 4 seconds that I did that. It's just ridiculous. Okay, so there is a clear, there is a correlation between rational exponents or fractional exponents and radicals. Okay, so the idea is very simple. It's any base raised to the m over n power, okay, is the same thing as that base to the m power with the n index. Okay, so this is the index. Okay, so this is typically, square roots are the second index, but we don't put the 2 there because it's just square root is a square root is a square root. But if it was like, a cube root, there would be a 3 here, the 4th root, whatever. So we can call that an index because sometimes it gets a little bit crazy with the numbers. But this is the correlation. This is the relationship that has that's going on, right? So let's take a look at a couple of problems here. So this is 7x raised to the 4/3 power. Well, 7x is a term all in of itself, okay? So 7x has to be represented underneath the radical. Now, think of it like this. Whatever the numerator is of your rational exponent, it stays as part of the exponent. The numerator doesn't go away. The denominator, well, whatever, we don't care about. So this is 7x to the 4th power, right, with the 3rd index. Now, this is, okay, so this is not exactly my answer. Now, the reason we do that is because that means that x is only being raised to the 4th power. What the idea here is the index needs to be raised, the index of 7x needs to be raised to the 4th power. So, yeah, I caught myself there, but I didn't really because you saw it. So the numerator needs to stay on the outside of the parentheses, and we can go from there. Hopefully, I won't make that same mistake again. Okay, so x to the nth power is going to turn into the nth index of x to the n power, but the m, I guess I should kind of put this out here like this. Right? Maybe it'll be a little easier to see. Okay, so 3p stays underneath the radical. 5 is the index. 8 is the exponent. I tricked you. I didn't really trick you. I just kind of worked it out. Okay, so let's see if we can get the next 2. Pause me, see if we can get the next 2. And if you made the same mistake I did, it's totally fine. Okay, there doesn't need to be a parenthesis here because it's 1. See, I should have done these 2 because they were easier, right? No parentheses because it's 1. But let's say that was a 2 numerator, parentheses go here, and that makes it 2. Darn, you got me. Okay, let's go to the next set. Now, the next set, obviously, would be the reverse. Us changing the radical form to exponential form. Okay? So let's erase this. Let's try them together. I'll do the first 2. Well, hold on. Let me take a look at them. Which ones are easier? Oh, the first 2. Absolutely. I'm going to start right here. So this would be the second index of k raised to the 1st power. Well, anything that's just a square root is k to the 1/2 or whatever that is to the 1/2 power. Okay? Oh, yeah. I wasn't giving you that one. That one's too easy. Okay, so again, 4r stays on its own. The numerator is 4, and the denominator is 3. Well, let's go ahead and put that in parentheses because, well, I guess it doesn't matter because it's still a term. But we want to make sure that we do not isolate r to the 4/3 power. Now, if there was something else here, then it would be like distributive property. But it's 4r raised to the 4/3 power. So whatever r ended up being, you would have to multiply that first and then raise it to the 4/3 power. We don't want to isolate the r just to that by itself, okay? So go ahead and I will pause you. Try 7 and 8. What in the heck? Hold on. All right. Okay. So 2n stays, 3 stays on the top, 5 stays on the bottom, parentheses all around basically. Okay. Don't make the same mistake I did. 10p, 7 to the 5th power. Pretty simple. All right. Goodbye.